So far we're working here. It's DJ derivative just going over there.
What are you doing this for?
To show you that it's exactly the same formula.
Different, but same.
I already knew that.
Your table mate didn't. You can side-eye me all you want.
Why are you shaming me?
I'm not shaming you.
Yes, you are.
You didn't think it was. He's literally
Joey,
proving
is
to you
zero
that it's the same formula.
Can you let me cook? Hold on.
Is zero
He's
squared
up
one?
there trying to stand on business right now.
Okay,
Square is 0.
just give
To
me a
the-
minute.
Something to the square,
So,
something to the 0 power is 1.
So how did I still get t squared?
I don't know what you're.
Because you forgot the threes.
I have threes now.
Did you take out an H?
I did take out
How
an
many
H.
H's did you take out?
1.
Did you forget the H squared? So
This is 2 now.
and it's H to the third again. Your 1, 3, 3, 1 should be T to the third plus 3T H to the second plus 3T squared to the H times H plus H to the third. And then you have a minus T to the third. So there's 2, 3, 4, 11.
oh shoot.
Yeah, dude.
I think my threes in the wrong spots. Hold on.
Limit as h approaches 0 of t cubed plus 3t squared h plus 3th squared plus h cubed
Oh, you do 3t squared.
minus t cubed all over h.
It's not funny.
Did not get. I got 3T squared plus 3TH plus H squared.
Yeah, but you got to plug in the square.
You do it.
Check it out.
So then if I'm crossing off h's, then this h cancels out with that h. One of these h's, so I'm left with just h there. One of those h's, so I'm left with h squared there. So then that's going to leave me with 3t squared plus 3th plus h squared. Now we could send h to 0. And so that gives me an IROC at any time t of 3t squared.
How? No, I didn't. I have to. Cool. I was wrong.
Okay. Which then, now, if we do that, now we can say, all right, what's the IROC at this time, this time, this time, and this time? And you can do it boom, 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 boom. Okay? At 0, it's 0. At 1, it's 3. At 2, it's 12. At 3, it's 27.
So when we have to find the IROC, so like sometimes you know how they give you a number and then sometimes they don't. So do you recommend that we do it with this method with like approaching 0 all the time and then plug it in so that in case it asks you for more, you can just do this all the time instead of doing like the exact number? Okay.
Wholeheartedly agree. Okay. So using the IROC at any time, find the instantaneous velocity. We just did that. Okay. So the position function is going to be f of t, and that was t cubed. So that tells us where we are in terms of position. The velocity, the IROC, we called that the derivative yesterday, and we said that that was what we just found. That was 3t squared. Okay? So then what's the IROC at 0? 1, 2, do you have any more?
3, 4, 5, 6.
3, 4, 5, and 6. Okay.
Wow.
So find me the IROC all the way down to 6.
You're always a student. Always
Yeah.
learning.
Always learning.
Better.
Never stop learning.
There you go.
IROC at 0.
0.
0. I think let's just go meters per second here. Okay. IROC at 1.
3 meters per second.
We'll screw them up in the final. We'll go like inches per second in the one. Yeah.
You know, you do that.
We would.
I know.
At 2.
12 meters per second.
12. 3.
27 meters per second.
4, 5, and 6.
48 meters per second. 75 meters per second. 108 meters per second.
Do we all agree with those?
Yes.
Okay. What is our object doing?
Accelerate.
It is accelerating, yes. Okay. Okay. And we know that by looking at the rate of change of the rate of change. Okay. If the rate of change had stayed at 3 meters per second for every single one, okay, it would be going at a constant speed. It wouldn't be accelerating, it wouldn't be decelerating. Okay. What happens if, so we went to 3, then we went to 12. What if this one would have gone back to 3?
It would
It's
be accelerated and
and
decelerated.
Pressing on the
So it
brakes.
accelerated and it decelerated, okay? And then if it went back to, so like, what if then if this next one was negative 14?
Well, now it's going
Direction.
backwards.
Doesn't T
Now it's
stand for
changing
time?
directions.
What?
Does T stand for time?
So like at like 4
It
seconds,
changes.
it
It
would
changes
backward.
directions.
And motion.
So it would have changed direction. So what can we say happens between, in that case, if we were at, what did I say this was? 3, and then this went to negative 14. What can we say happens in between 3 and 4 seconds?
direction.
It
It
decelerates.
what? It stopped. So we would have a 0 somewhere in there. It would have stopped because it changed directions. Okay? So it's got to stop in order to change directions. Okay? Alright. And then let's go even further. So then let's say, so now we're going in the negative, and then let's say that this was negative 31, and then negative 47, and so on and so forth. What can you tell me about the object here in that 4 to 5 second or 4 to 6 second range?
Actually, tell me it's accelerating or decelerating.
It's accelerating the other way.
It's accelerating backwards. Okay, it's getting faster. The rate of change is getting faster, so the velocity is getting bigger, but it's going in the opposite direction.
It's like a lunch.
Oh, I like that analogy.
Exactly. Okay. All right.
Go do my job.
Well, you know, it happens. Go for it. Abs back now. Now we can go. Limit. H goes to 0. Of f of t plus h minus f of t all over h. Okay? So that's going to be 1 over 2 times t plus h, then minus 5 minus 1 over 2t minus 5 Alright, so this is 1 over 2t plus 2h minus 5 minus 1 over 2t minus 5 all over h. Okay. So, what are we thinking here?
Gotta multiply the bot, like the bot, 2t minus 5.
So what you're telling me is this becomes 2t minus 5 minus 2t minus 2h plus 5 all over 2t minus 5, 2t plus 2h minus 5, and then can I keep change flip this right away?
Yeah, then just put the h, right?
So I'm sorry, what? Can you pause that?
And then you can start canceling the 5 and the 2.
Whoa. Oh, up top, yes.
Up top.
Up top, yes. What do I need to pause? Put a pause in.
Wait, never mind, I understand. Keep going.
Yeah, just multiply.
I got rid of the over h by multiplying it by 1 over h. I did the keep change flip in my head and just threw an extra h on the bottom.
If you keep changing the 1 H be on the top.
No,
Because it's h.
it's h over 1, so the flip would make it be 1 over h.
That's right, I know.
And you can just cancel the 5.
Okay? So these cancel, this cancels, and
h cancels.
this cancels that. I'll back that up one step so we can actually see that. Okay? So then this cancels this. So now, oops, there. Tap the brakes. Now I got one too many. There. Okay? So now this becomes, turn my page. This becomes the limit as h approaches 0 of negative 2h over h 2t minus 5, 2t plus 2h minus 5. And then these h's now can cancel out because of the multiplication. So now we've got the limit as h approaches 0 of negative 2 over 2t minus 5, 2t plus 2h minus 5. Gets me there.
You plug in 0 for h.
Can we?
Yeah.
Because it's not going to give us a 0 denominator, right?
So it just gets rid of that 2h.
So it just gets rid of that 2h. So if I send h to 0, then my RoC will be negative 2 over 2t minus 5, and then 2t minus 5, so we'll call that squared.
That's basically.
Up here?
Yeah, it's all minus, so we're all confused. I feel like the price wouldn't cancel.
Because I had to multiply by the minus there, right?
Oh, okay. So
By the negative 1, so it became plus.
Okay,
Yep. Okay? So there's our RoC. Now that we know that our RoC, oops, is negative 2 over 2t, right, was it plus 5?
Minus 5.
Minus 5? Find me the RoC at those 4 points, or at those 4 times.
This line goes back down.
It never stops.
Okay, well let's check this out. So at t equals 0, what is my RoC? Negative 2 over 25. Okay. At 2?
2. Negative 2.
Negative 2.
Negative 2.
You're a little late.
Okay.
Negative
Next
2
one's
again.
also
At 3 is negative 2 also. and then it's -2/25. Okay, let's logically talk. What is this object doing?
It's accelerating the opposite direction,
So it's accelerating backwards.
and then it decelerates.
And then,
Okay.
and then it remains constant for a bit.
So from the start, it starts going backwards, right? And it accelerates, right, to 2 seconds, and then from 2 to 3 seconds,
Constant.
it stays the same. It stops accelerating, okay, and then what?
It decelerates.
It's decelerating, but it's still going backwards.
Oh yeah.
So it's kind of like he was pressing the reverse pedal, started going, and then he just let off the reverse pedal and just kept rolling.
And just kept rolling. Okay. All right. Follow-up question. RoC still here? When does the object stop?
When he equals 0.
Okay. When does it stop? Give me a time frame. When does it stop?
Give me a second.
Why would it be 2.5 G equals -2 on the top? It never stops. It never stops. It's imaginary.
What
It
happens
happens at some
at,
point.
what happens at 2.5?
It's still going 2 miles an hour.
Yeah, 2.5 is between
It's
2
just
and 3.
backwards.
It's just go over 0 though, right?
What do you mean?
Because it's gonna be 2.5 times 2 is 5.
But at 0 it's not,
5.
because it's 0 minus 5.
0 squared.
So you need 2t to equal 5. So
No, what Jake's saying is correct.
what about 2.5?
What about 2.5?
It's between 2 and 3. It's literally.
Oh yeah, but you were saying 2.5, you agree.
Right. So what's happening at 2.5 seconds?
It's
It's
not
not.
happening.
It's just not happening, right?
It doesn't exist.
I
That's
stopped.
what I was saying.
And did it stop at
I
2.5?
literally said it doesn't
Hold on.
exist.
Hold on. Sadie's saying it stopped at 2.5.
But it shouldn't have because
It's undefined.
Well, it doesn't stop at 2.5.
because
There's
it's
a
going
negative 2
constant
on the
between
top.
2 and 3. It's constant speed.
I get what you're saying, but there's a 0 at the bottom at one point. What do you mean there's a 0?
If you plug in 2.5,
It's
you get an
You get zero.
undefined speed. You don't get 0.
You get it.
You
You
get-
get on the bottom.
Yes. You get undefined speed. So there's a hole there, right? So we don't know what's going on there.
What are we supposed to do?
Okay. When does it stop?
It's an asymptote. It doesn't stop
Why not?
because you can't.
It just
You
doesn't
can't
exist.
have a
denominator of
It
0.
just doesn't exist.
It just doesn't happen.
Stopping has nothing to do with the denominator of 0.
okay,
has
so
a
it's
break-
gonna equal 0, but then like
No, it does not. Again, let me reiterate. This time, actually, listen to the words that come out of my mouth. The denominator has nothing to do with it stopping.
It has to do with the 0
Because there's no variable.
Yeah, it's because there's no variable on top.
So it never stops.
It never stops.
It never stops because the numerator in a fraction, the numerator tells it when it's 0. Okay? When the numerator is 0, the fraction is 0. And this numerator can never be 0. Okay? So we found the glitch at 2.5 seconds. Where's the other glitch?
At 0.
At 0. Right? At 0 seconds, it's already moving. At 0 seconds. Because we just said it never stops. Right?
So this wouldn't be a good equation.
Okay, right? Well, that's the fun part about math. And next year, you'll be able to define all of those conditions and
I don't know.
all that fun stuff.
I wish we could just divide by 0. That'd be kind of cool.
How did you think of 0? Like,
You think about it, 0 is 0. It's from the shell. Is 0 a number?
0 is a number, yes.
But if you think about it, it's like
Mhm.
Joey, why are you on right now?
it's nothing.